So next up we have, and I'm gonna get this right, Harald Zeitlhofer. Close. Okay, so yeah, I think we can just bring you straight in, mate. We should get going. So okay. Harald, thank you.
Thank you. Yeah. Actually, I'm pretty impressed. It was one of the best pronunciations ever that I saw around the world. When I was young, I always thought actually that this name was pretty easy to be pronounced, Harald Zeitlhofer. But the more I travel, the more I see that it's not that easy, obviously. I work as a technology strategist at DYNATRACE. DYNATRACE is a company in performance monitoring, application performance monitoring. Before I joined DYNATRACE, my background is actually database and web development, web applications, always with a main focus already on performance. So not just making a database itself fast, but how I can change an application structure or application behavior so that it can use databases efficiently, for instance. I first used PHP, it was back in '99, I think. It was PHP 3, yeah. It was during a database project, so we worked on it was an Oracle Forms project, and we had to implement some web-based reports. And colleagues of mine worked in a combination of SQL Plus and Perl scripts, and it was rather complicated to get something out there. And I heard about a new tool out there that on the one hand has easy capabilities of attaching to for building websites. On the other hand, can access the database directly. And so I tried that out, and colleagues of mine said, better not touch that, because you know that new things coming out, they will never be really successful out there. The same as we thought about the internet in general, maybe. Now, 20 years later, or almost 20 years later, we saw that it was definitely quite successful. I love to discover new things, not just in technology, but also in geology or speleology. Well, going down to caves, a cave is nothing new. They are millions of years old, but actually the passages that we find there are new for us. Yeah, well, you might hear it in my accent that I'm not from here. I'm from Austria, the tiny little country in Europe. Yeah, there's not much difference between Austria and Australia. It's just an A and an L. And yeah, maybe Austria is a little larger in size than Tasmania. And you see our shoreline is not that long as yours here. But apart from that, there's not much difference. You know that, so we don't have that animals. But why we are here today, so scalability of applications, PHP applications. And let me start that story with a phone call that I got from a friend. I worked with him on different projects, on database projects, before I joined DYNATRACE, and then he was one of the founders of a startup. And one day he called and said, hey, you performance freak, we have a problem with our web shop, and we have to scale up, otherwise it won't work. And I said, wait a minute, what do you mean you want to scale up? What's your problem? What's the background? How does the application look like? Yeah, well, we have a Magento web shop running here. It's hosted in a EC2 instance, and it's so slow, and we plan to launch new instances in the EC2 now to so we can serve the requests. And I said, well, be careful. So when you say it's slow and you want to get that sorted out by scaling up, scalability is not performance, not directly. So for sure it has to do, but it does not automatically solve your problems here. So when this is performance, then this is scalability, right? But on the other hand, also this is scalability. While here the overall performance might be not that good as here, maybe. But on the one hand, scalability, on the other hand, performance. Does performance matter at all when we talk about scalability? And generally spoken, the answer is yes. So when we look back a couple of years, so the years where we thought that the internet is maybe one of that new things it's not going to be that successful. The Amazon homepage looked like that. Well, lots of years later now, things have changed. Homepages have changed, luckily. But not only technology has changed, but also the culture has changed. How technology is consumed, how technology is used. And especially in the last 8 years, there have been a couple of real revolutions here, but one of these revolutions was this mobile revolution that happened out there. A new digital customer has emerged. And the smartphone adoption right now is around 95%. And this generation where the smartphone adoption is that high is already the largest generation in a Western workforce. And this generation is increasingly less patient with performance issues, with digital delays. When we ask these users, these people out there, around 60% said that the single most frustrating experience is a web page loading slowly or not loading at all. And with this digital culture, this connected culture, these customers, these users are more and more willing to take that experience out, to share their experience in social platforms, in forums, you can rate a certain application in the App Store, and once it's got bad rates and you're a startup, the only option that you have is to rename your startup and start from scratch. Once it's not working anymore, you have to start again. So in the end, it's all about the user. We want to create a happy user, a satisfied user out there. That's the main purpose. The end user sitting on a device, on a desktop device or on a mobile device. Well, there is maybe one other reason, and these are these guys. Google is already using page speed for ranking search results. And there's an entire industry already behind that, search engine optimization. So when we have an online business, we don't want just to be found on Google. We want to be not only on page 1, we want to be on top of that list. And performance, actually time to first byte of our website, is one of the key factors for ranking in Google. It's not only speed. It's also about availability. How many systems are there out there where the 404 page is the fastest page in the system? Actually, we don't care how fast that page is. When it's not available, it's not available. So, and we have these two factors now, performance, availability, but scalability is still a little more. It's not just how fast our website can respond to a web request. That's what the users expect. It's also how fast we as an application, as a service provider, can respond to feature requests from a user. We are no longer in these days where we had weeks or months to implement new features. When features are requested by the community, we need to implement them fast. We have much faster release cycles now. We have to react on that. And we have to react on changed load conditions. So especially during a peak season, we plan certain marketing campaigns. We have partners broadcasting on YouTube with hundreds of thousands of followers or millions of followers. They announce services of us with a link in the remark section in YouTube. All of a sudden, we get a peak of load on our website. We have to be able to react on that. So to scale our application properly to fulfill these demands. But when we have a complex environment with a lot of technologies, a lot of different databases, different languages maybe, different web servers, caching layers, different browsers, where do we start to scale? And especially when we talk about these larger applications and high performance, we hear a lot of time, as we are performance consultants, we hear a lot of time, well, PHP might not be the best choice for that because PHP is not fast. Well, it's true, definitely. PHP is, for instance, slower than Java in execution. But the good news is PHP is not the bottleneck here. It's so many other components in your entire stack that are much more relevant for performance hotspots. Like bad front-end design, so overloaded pages. When we have pages that take, and this page, when I last measured it, took 2 minutes to fully render. We don't actually care about milliseconds in the backend. So how should we start here? What do we need to have done before we can scale our application? We need to break the application down into smaller parts in order to be able to scale these parts where we have the requirement for it. I'll give you an example. In a traditional LAMP stack, we have our server running on Linux, Apache web server, PHP, MySQL. We send web requests from the browser to the server, and for each incoming web request, we create a new process for the Apache web server and load all the modules, load mod.php, load other modules that we have defined there, which might be quite resource consuming. So if we expect a higher request rate now from the web, especially for static resources, for instance, or even for cached resources. Cached resources in the browser can still create web requests. When we have conditional caching, like using the entity tag, the browser sends a request to the web server for that file, including the hash, or what we use for the entity tag. The server then decides whether the content has changed or not, and if not changed, sends back an HTTP response with code 304, not modified, but no response body. But we still create round trips, we still create requests to the network, to the web server. And for all of these requests, we have to launch a new process in Apache, or actually it's done automatically, but with every module loaded, mod.php loaded, other modules loaded, even for such requests. So to split that up now, web server and PHP engine, for instance, we could consider using a web server like Nginx, and Nginx processes these static requests, or requests for static files, for much more efficient than Apache does it. And dynamic requests for PHP, for instance, are forwarded to the fast process manager, PHP FPM. And these requests could be processed on a separate server or on the same one, and we split it up already in 2 different services. And by starting up either statically or dynamically multiple worker processes for PHP here in the background, we have actually already started to our first kind of horizontal scaling here. So we have a web server process on the one hand, and we have different worker processes for the PHP engine on the other hand that just serve PHP requests, just web requests where it's relevant. As we are using Nginx here in this example, we could do following. We could define, so where we send the requests to, this is the fast CGI pass is the command to forward these requests, and this is the name of the upstream block. If we define multiple servers here, we automatically have a load balancer. So we can run these worker processes for PHP FPM already on different backend servers. The next step in horizontal scaling that we've done here. So one web server, different PHP servers, each of them running multiple worker processes again. So to optimize applications, to optimize performance here, would that mean that if we have slow PHP code, we just launch 100 instances of PHP engine here, and then we are fast? Or should we maybe consider to do some optimizations first? Well, on the one hand, there are scaling gurus out there telling, don't optimize, just scale. Infrastructure is not expensive. Just launch more instances. But I do not agree with that. On the one hand, it's my intention, always do your homework first. So start where really the problem is and then try to make it better. Or another example of scaling an application, if we have the requirement, we have to catch more mice. So, given situation, we have 2 cats, cat 1, cat 2. If we start scaling horizontally here and launch more instances of these cats, we might not be very successful. However, if we optimize the cat first and use that cat for scaling horizontally, that might be a much better option. On the other hand, but when we do optimization, we have to focus on what we need. Do not over-optimize. We don't need killer cats here. We just want to catch more mice. So don't invest too much time, too much money in doing that. Focus on what's required. Back to the example where I started with, when my friend called with the Magento shop. We did the same there. So we analyzed what was going on in their code. And besides the fact that they had not quite bad as the overloaded page, as I showed you before, but even the front-end design was not really good. Let's keep it that way. But what we saw immediately when we broke down performance into different tiers, so PHP, web requests, database, web server, PHP execution itself, we saw that PHP, the application, was the major hotspot here in performance. Breaking that down further, we identified 3 major hotspots. On the one hand, it was a less CSS preprocessor. On the other hand, a social login module and slow PHP execution. I'm not saying that these issues are always the main issues. In that case, these were the issues. So in detail, the less CSS preprocessor, which, who knows less CSS preprocessing? Quite a few. For the other ones, you can add, let's say, code functionality to your CSS files and create CSS easier. You can reuse functionality, use variables, function names, everything. But they had development mode active for production. So that means for every single web request they came in, they had to recompile all these less source files, which is not the intention for production. For production, you precompile it and then use plain CSS. And yeah, in the method breakdown, we saw that the time spent there was quite remarkable. The other thing was a social login module that they used, and they configured just a couple of services. And Yahoo and Twitter, for instance, were two services that were disabled, so they didn't use it. Something else is disabled here? Seems to be the okay, back, thank you. However, the application did calls to that backend services. And as this was not configured properly because they didn't use it anyway, there was some really delay in there. So this was one of the other performance hotspots. The third one was slow PHP execution. Well, it came out that they still used PHP 5.3 back then without op caching, and just by upgrading to 5.5, it was 5.5 back then, we did a lot of optimization here. So always use latest versions, and especially now with PHP 7, we heard a lot of it. Thank you, Zef, for providing such great new PHP version. Yeah, your applause. Your team. Well, so what we did then when we had fixed these issues, so optimized code there, did our homework, we had these components, these smaller services of Nginx web server and some worker processes for PHP. And in addition to that, we were able to launch new instances with the same functionality for further scaling here. And using that in EC2, it's pretty easy to use an elastic load balancer on that. So you can dynamically start up or shut down services running there, and traffic is automatically distributed to these backend services then. So on the one hand, we can launch these instances manually, or we could have dynamic scaling here. And as deployments, modern systems are no longer really static, this is a pretty cool feature that we can use, especially in infrastructures as a service like AWS. As an example here, we have an application where at 7 in the morning, load is not quite high, so we have 2 backend services running for serving the requests. At noon, there's more traffic. We scale up. We have 7 instances running there. At 7 p.m., we can scale down again because traffic is low. And but maybe we need it in a different availability zone because in a different geographical region. It's pretty easy in EC2. EC2 also provides functionality. We have a lot of out-of-the-box metrics there that we can use for these elastic scaling, but it's also easy to add custom metrics. And in less than 20 lines of code, we have implemented a script here that on one hand determines metrics from a monitoring system, on the other hand feeds it to the load balancer. Can be easily done there. But for the Magento project, what we did when we expected higher traffic because of marketing campaigns, so from an environment where we had 10 instances running, we did first upscaling to 48 instances in the background. So we had one front-end server here, so the web server, and then 48 PHP servers in the background. Well, just in time, traffic increased as the marketing campaign started, and then I got a phone call again. Please help us, we are down, we are offline. Well, what happened? All of a sudden, database contribution was on a maximum here in response time breakdown. And when we drilled down further, we saw that we had executions of certain SQL statements of 30 seconds and more. And not just single ones, but a lot of slow statements here. We furthermore found that we had almost 4,000 database statements for a single web request. So one request coming in, 4 statements going to the database. So two things happened here. On the one hand, we again found code that was not really optimized. In that case, there was another library in use, Minify CSS, also for front-end optimization. And the problem there was this created a lot of requests, a lot of statements to the database. It was not a problem before scaling up because the database was easily able to process that load. But as we had so many instances running now, it just came out that the database in the background was undersized. So for database access, consider to size the server in the backend properly because this definitely has to process the web requests from all your application processes now, but also consider optimizing here. So reduce connections, reduce SQL statements going to the database. Leverage caching. Caching. Caching is not caching. So there are so many different options of what we can cache, how we can cache, why we can cache, whether we should cache at all. We already lost a couple of words about client-side caching. So let's have a look at the server. I want to mention, I don't want to go too much in detail here. I want to mention using Varnish. Varnish is a very popular caching layer that has a lot of cool integrations with different frameworks. Basically, there are two options on how or where to implement such a caching layer. On the one hand, the incoming requests could go to a caching layer first, and only content that's not available in the cache goes to the web server and furthermore to the PHP engine. Another option is to have it, let's say, aside the web server. So when we consider the web server here not as a web server but more as a reverse proxy that's sitting in front of our environment and in that case also serving static content. And so the web server Nginx acts as a reverse proxy here, sends requests to Varnish. If content is not available there, forwards the requests to the PHP tier. By the way, this is my preferred option, but this is a kind of philosophy, so we see both options out there regularly. Another thing about caching is Memcache, using Memcache. Who is using Memcache? Who's using Memcache for session storage? Yeah, right. I'll give you an example here where I'm not using Memcache as session storage, but as for data storage. This is a screenshot from the Austrian cave management system, geographical information system, my baby, by the way. So I've created that, and now I'm operating that. It's meanwhile not only used in Austria, but also Germany, France, UK, so different countries in Europe. And one feature is here to have a map overlay, so to display caves on the map. And when you move the mouse over a certain area here, you see details, features, so kind of metadata that are stored there. The calculation for these metadata are stored in a document database, but other features like coordinates that are displayed there have to be calculated depending on settings for the user. So we store data in a geographical coordinate system, so latitude, longitude, but we have to display it in custom systems, custom transformations. This requires quite a lot of time, especially when we have large caves here in the background that we want to display. So what happened here was we created a job in the background which was executed on a different server, which calculated this structure in a GeoJSON format and stored it in a Memcache server. And by using this URL-like key in Memcache, it was now pretty easy to create the configuration in Nginx where we forward a request that's coming in for that location, so for that URI pattern, to Memcache. We don't need to implement these access logic in PHP. We can do that from Nginx directly. So actually, that was the main reason why we used Memcache Tier and not other systems like, for instance, a MongoDB, where we would have had the option to store the data also for a longer time. On the other hand, it's a requirement to calculate that regularly anyway. Because when data are changed in the background, we want to have fast changes here for these data. Well, by doing that, so it was one example. We also split out other functionality of the base system and created jobs, other processes providing these data. What we did actually, without knowing the terminology that is used now for that, actually we created our first microservice architecture. We split that big monolithic application that we had into smaller services that were easily able to be scaled now by their own. So if there is a request, for instance, to need to run more instances for this calculation because whatever the data structure gets more complicated, we don't need to scale the entire application. We just can scale that one service. Depending on requirements, if we have smaller pieces, it's easy to get that properly sized. On the other hand, the more different services that we are using here, that are involved in communicating with each other, the more complex the system gets, the more points we have where problems could occur. So when we consider our classical tiers, a browser, cache, web server, application, PHP, maybe other languages as well, database. So one option is to have logging, profiling, monitoring functionality in every single part here. And when we are responsible for the web server and the transaction is slow, the entire web request, and we can see, okay, the web server, it's not our fault, we can blame it to the others. Well, yeah, on the one hand, the blame game is nice, but it does not really help us in the end. So what we actually want to achieve is we want to solve problems. And that's why it's important to consider that as a general system. And this is where application performance management comes into the game. With application performance management, we actually do that. So we not only monitor a certain process, but we monitor everything in that application. Starting from the user, so what's happening in the browser, and starting with relevant metrics. So is the user satisfied? Is the user frustrated? If we have certain results here that we see, okay, maybe we have a region here where we have really only frustrated users, or also down here, maybe it's too far away and just CDNs are not available or whatever, but we can break down further then in an APM tool. For instance, to see what is my user doing, what are the user actions, what's happening there, what's the response of every single user action here. Is the user satisfied, frustrated, not only with his overall visit, but with a single action that he's performing. We can drill down further than really into code level on our server side. So we see when the user is clicking on a certain button in the browser, what does happen in the background here, what does happen in our PHP tier, what's sent to the database. But not only the transaction is monitored, also infrastructure, hosts, virtual machines, Dockerized environments, processes running there, like web servers. So we see traffic that's coming in, sent out to different backend tiers. But also the database, what's happening in Oracle in that case. Or the PHP tier. So we see how is the PHP engine performing, and also what different modules, what different extensions consume what amount of response time. But not only transactional or infrastructure data, but really business relevant information can be captured there and brought into conjunction with performance data. So it's easy then to find out if I have an increased number of web requests, does that affect my performance at all? Or does that affect my conversion rate, my revenue? I'm able then to create these business relevant data, to set priorities on where I need to fix, on where I need to scale my application to handle load properly. So what have we learned about scaling today? Yeah, on the one hand, it's about creating a well-sized environment to make sure we have high availability, high performance. We can handle a huge number of transactions. And very important, we can react on changed conditions here. Not only load conditions, but also feature requests. We can react fast. The system is maintainable, so when we find problems, when we need changes there, we can do that easily then. And to ensure that, to find problems properly, for sure we have to monitor that properly. Well, that's it from my side. I think I'm in time, right? Oh, perfect. Yeah, as I've mentioned, APM tools, there are a lot of tools out there, so maybe you are already using tools for APM, maybe not. Feel free to try whatever there is. If you're interested, we can show you something here. We have free tools that can be used for free forever, so everything available from our side. And yeah, if there are any questions, please feel free. Okay, maybe if there are questions later, I'll be here all day anyway, so in case, let me know. Thank you.